Hello everyone. In my last video, we see that there is a correspondence f between complex homomorphism and the maximal ideal by f of phi equal to kernel of phi. Now in this video, I am going to explain the bijection of f. F is bijection. So first f is 1 1. Let phi and psi be two complex homomorphisms of x such that kernel of phi equal to kernel of psi. Let x belongs to capital X be any element. Then phi of x minus phi x into E is phi of x into phi of x minus phi of x into phi of E. Since phi is linear, so and as phi of E is 1, so phi of x minus phi of x is 0. That means phi of x minus phi of x into E equal to 0. That means phi image of x minus phi x into E is 0. So x minus phi x into E is in kernel of phi, and kernel of phi is equal to kernel of psi. That means this element is in kernel of psi. So psi image of this element is 0. As a result, psi image of x minus phi x into E is 0. Since psi is linear, so psi of x minus phi x into psi of E is 0. Psi of E is 1, so phi of x minus psi of x minus phi of x is equal to 0, giving phi of x equal to psi of x. And since x is arbitrary, so it follows that phi and psi are same. Hence f is 1 1. Now next f is 1 2. Let m be any maximal ideal of x, then m is closed. So we have a result that maximal ideal is closed, and so x by m is a Banach algebra. So it's a standard result in functional analysis. We claim that every non-zero element of x by m is invertible. So suppose to the contrary, assume that there is a non-zero element a plus m in x by m, which is not invertible in x by m. Then m plus ideal generated by a is a proper ideal of x. How? To see this, it is sufficient to see that m plus ideal generated by a does not contains 1, because if it is contains 1, it is improper. So it's a proper ideal, means it does not contains 1, and if it contains 1, so what happened, we see 1 belongs to m plus ideal generated by a, means implies 1 equal to m plus ax. Small m is m and x is ax in ideal generated by this. So 1 plus m equal to m plus capital M is m and ax. So ax plus m, and ax plus m can be written as a plus m into x plus m. And since we are dealing with commutative Banach algebra, so the other part can automatically done. That is x plus m into a plus m is 1 plus m. That means a plus m is invertible. A plus m is invertible, but which is a contradiction, because a plus m is, we are taking a plus m is not invertible in x by m. So 1 does not belongs to here m plus ideal generated by. So m plus ideal generated by a is a proper ideal of x. Okay. Moreover, a plus m is non-zero, and m is a zero element of this. So a plus m not equal to m, and so a does not belong to capital M. Thus we have the inclusion m proper subset of m plus ideal generated by a proper subset of x. So how this inclusion occurs? See, a can be written as a can be written as 0 plus a into 1. So a belongs to m plus ideal generated by a, but a does not belong to m. So this inequality subset, it's a proper subset, and this is a proper subset. How? Because this does not m plus ideal generated by a does not contain 1, and X contains 1, so proper. But this thing, this inclusion cannot be happen because M is a maximal ideal. No proper ideal contains capital M. So this is not happen. This is not happen. So we get a contradiction. So our claim is established, that is, every non-zero element of X by M is invertible. Thus it follows that X by M is a Van algebra in which every non-zero element is invertible. So hence by Gelfand-Mazur theorem, X by M is isomorphic to C by an isometric isomorphism F from X by M to C by F of lambda into 1 plus M equal to lambda. Now let pi from x to X by M be the natural projection given by pi of x equal to x plus M. Now this natural projection is an onto homomorphism. Then the composition F compose phi is a function from x to C, because this is from x to X by M and F from X by M to C, so composition is x to C, and which is a complex homomorphism, so that x belongs to kernel of F compose pi implies F of pi of x is 0 and pi of x is x plus M, so F of x plus M is 0, and F of 0 element is 0, means F of 0 element in X by M, x 0 element in X by M is 0 plus M, so F of 0 plus M is 0, so this F of x plus M equal to F of 0 plus M, and since F is 1 1, so x plus M equal to 0 plus M, that means x plus M equal to M, so x plus x belongs to M, and all these steps can be reversed. That means kernel of F compose pi is equal to M, hence it follows that this is equal to M, and kernel of phi, kernel of this complex homomorphism is F of complex homomorphism. That means F is onto, hence F is 1 1 and onto, so the correspondence F is bijective. Thanks. If any mistakes in my video or any doubts, you can comment. Thank you.